Hello and welcome back to University Physics. So we are solving quantum mechanics and we are in chapter 2. So let's move to question number 2. And the question number 2 is two polarizers 1 and 2 are kept one after the other with their transmission axis parallel to the vectors. So the transmission vector of the first polarizer is this 2e2 cap plus 3e3 cap, and transmission axis for the second polarizer is 3e2 cap plus 2e3 cap, and a photon of light traveling in the x direction. So this will be E1 cap basically, and this is y cap, this is z cap, this is y cap, and this is z cap. So photon of light traveling in x direction having polarization, that is the direction of the electric field is along the y direction, falls on the polarizer 1. So we have to calculate the probability that the photon will get transmitted through both the polarizers. So the situation is, suppose two polarizers are kept like this. I'm not drawing the exact diagram of the polarizers, as we are not dealing with optics, we are solving quantum mechanics, so forget about the diagrams, just follow the concept. So this is polarizer 1, this is polarizer 1, and this is polarizer 2. So light beam of light falling on polarizer 1, it gets transmitted through the polarizer 1, and the light which passes through the polarizer 1, it is made to fall on polarizer 2, and some part of it gets transmitted. So we have to find the probability that the photon will get transmitted through both the polarizers. So the direction of the photon is along the x direction and its vibration is along the y direction. Photon is the electric field for the photon is along the y direction. So let's call it, so let's change the notation. So this is the transmission axis of the first polarizer. So let's call it ket psi 1, and let's call it ket psi 2, and let's call it psi initial, and let's change the notation x cap, y cap, z cap. So basically this is E3 cap, this is E2 cap, and this is E1 cap, and we are changing the notation here in Dirac form. So let's call it ket phi 1, ket phi 2, and let's call it ket phi 3. So from the information we are given, what we have been provided in the question, we have psi initial. So psi initial will be phi 2. Psi initial will be phi 2. That is along the y direction. That is along the, and the transmission axis for polarizer 1 and 2 can be written as ket psi 1, and this will be equal to 2 phi 2 cap plus 3 phi 3 cap, and the normalization factor, that is root under 13, that is basically 2 square plus 3 square, and the transmission axis for polarizer 2 can be written as 3 phi 2 cap plus 2 phi 3 cap divided by root 13. the normalization factor. So we have to calculate the probability that the photon gets transmitted through both the polarizer. So let's first calculate. So let's call our PA, that is probability that photon gets transmitted through first polarizer, through first polarizer. So this PA will be basically the dot product of the initial state, that is psi I, with the transmission axis of the first polarizer, that is psi 1. And since it gives the probability amplitude and we have to find the probability, so obviously mod square. So let's calculate. Psi I is basically phi 2, and we have to calculate its dot product with psi 1, and psi 1 is 2 by root 13 phi 2 plus 3 by root 13 phi 3, and obviously it's mod square. So 2 by root 13 phi 2 with phi 2 and plus 3 by root 13 phi 2 with phi 3. So this will be 1 and this orthogonal states there, so this will be 0, and yeah, obviously it's mod square. So 2 by root 13 mod square, and so basically yeah, PA comes out to be probability that the photon gets transmitted through the first polarizer. So it will be 4 by 13. So now let's calculate that the probability of the photon that it get transmitted through the polarizer 2 after passing the polarizer 1. Yeah, so from the diagram, let's analyze it first. For polarizer 1, means for up to this part, the initial state for polarizer of the photon before falling polarizer 1 is psi I, and after passing through the polarizer 1, its final state becomes psi 1. Now for polarizer P2, the initial state is psi 1 and its final state is psi 2. Remember, its initial state is psi 1 and its final state is psi 2. So let's call PB, that is probability that photon gets transmitted through polarizer 2, and this will be PB, this will be psi 1, that is initial state for polarizer 1 before falling polarizer 1, initial state of the photon, with the final state that is psi 2 and its mod square. So basically this is 2 by root 13 phi 2 plus 3 by root 13 phi 3, and yeah, we have to calculate the dot product with 3 by root 13 phi 2 plus 2 by root 13 phi 3. So we have to calculate the dot product. So PB, sorry. it's PB. So yeah, probability B. So that will be equal to 6 by 13 phi 2 with phi 2 plus 4 by 13 phi 2 with phi 3 plus 9 by 13 phi 3 with phi 2 and plus 6 by 13 phi 3 with phi 3. Since phi 3 and phi 2 are orthogonal states, so these two terms, this will be 0, and yeah, obviously this third term will also becomes 0. And phi 3 with phi 3 dot product of phi 3 and phi with phi 3 and phi 2 with phi 2 will give 1. So this will be, and yeah, obviously it's mod square. Obviously it's mod square. So let's write the mod first. So 6 by 13 plus 6 by 13, this mod square. So PB will be 144 divided by 169, basically 12 square by 13 square. So the probability PB will be 144 by 169. And yes, we have to calculate the probability that photon gets transmitted through both the polarizer. So total probability, basically this is the probability that photon gets transmitted through both polarizer. That is both polarizer. That is means both P1 and P2. So the total probability P total we can write as polarized probability that photon will get transmitted through polarizer 1 and this multiplication sign for the and with probability P2 PB. So the probability PA is 4 by 13 into 144 into 169. So this is equal to 576 divided by 2197. So this is our answer.